Yo, what's up? What's up? Welcome back, everybody. It's good to be back. Today we are working on zlib. I'm calling it that because it's like zlib, and we're using it to learn zig. So you can put like a little bit in, like ig in there, and it's just like a worse version of zlib. And we're kind of trying to tackle a few things here. One is that I see like lossless compression kind of everywhere, right? It's just used a lot because it's very useful, and I don't really have a good feel for like what that actually is doing. It would be interesting to have like a good handle on that. So we want to learn about deflate, zlib, etc. Zig also seems kind of fun, so let's just kind of do both at once. And so where we're at so far is we've looked at this like zlib. If I look up zlib here, yeah, zlib. We've looked at this guy, and he says, hey, this is like a combination of two RFCs. One being like the header format of zlib, and one is deflate, which is like the actual algorithm that's used for compression. And so we looked at this like deflate thing, and deflate has a few types of compression. One is not compressed, because like compression wouldn't help. Like imagine like you already have like a PNG or something, you try to compress it, and it doesn't need to be compressed more. It would do nothing. So we just like copy paste the original bytes, because any compression that we do will actually add extra space. Then there's like a static Huffman compressed block, and I'll explain Huffman blocks in a second. And another is dynamic. So the idea is that these like Huffman trees are kind of like this representation of text where the most frequent things take up the least amount of bits. So if you had like the text like A, B, 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 C, D, you would like build up this tree where you say like, well, A is like the most common thing, so I'm gonna put this here. And then B is like the second most common thing, so I'm gonna put it here. And then C and D are the least common. And so if you like encode this as like paths that you take on this tree to get to this letter, then you have like A is 0, B is 1, 0, C is 1, 1, 0, and D is 1, 1, 1. And so you like build this Huffman thing. And so what they're saying here is that the static block is like a predefined tree, essentially, like based off of frequencies of, I don't know, letters in English, or maybe in like types of compression that they expect. And then there's also like a dynamic block, which is like, for this chunk of data, we're going to look at the character frequencies that we're compressing, and we'll like construct our new table based off those. And so what we've done so far is we've implemented like generation of this tree as well as decoding data based off of it. So if we look at our existing code, we can do something like sig build. Here we go. If I say, hey, I want to compress this string, quick brown fox jumped over lazy dog, we will generate a compressed format of this through the Huffman tree, and we can see a compression ratio of like 0.56, and then we can decompress it. Great. Sense, thanks for the cheers. Bits are, I think, money. I don't really know Twitch very well, despite being on this platform often. So appreciate it. Okay. So we have Huffman stuff ready to go. And so now what we want to do is we want to take our like Huffman coded thing and use that to decompress something that's actually been encoded with zlib. So what I think the plan of action for the day is to, in our program, compress something with zlib, then take that and try to read the header formats in a way that we can get to the point where we're at least like seeing these blocks of data. Then hopefully we'll be able to see that the dynamic Huffman representation on disk will hopefully be able to like decode that in some way and actually get some meaningful data out of it. That's kind of the plan for the day, but I don't really know how far we're going to get on each of these. Like, I don't know how far we're going to get there. So let's just kind of get going and see what happens. Let's just see where we go. Love you, but working with you, we're throwing hands. Whoa. Why are we throwing hands? You want to fight me? You want to physically fight me? Dude, if we were working together and you physically tried to fight me, you would probably get criminal charges, right? Like, what do you mean we throwing hands? Are you just trying to say that you're big and strong and I'm weak, little? No, I can't stay with you. I don't think oh, like I'm moving too quick. I see. Kick stream. Yeah, in a kick stream we can throw hands as much as we want. Okay. So let's see. First thing to do is we want to like pull in the actual version of zlib that we're trying to replace. So I've been like experimenting a little bit with like C interop with Zig offline, and it seems like pretty fucking sick. I think like the pattern here is that you create this like block, and you say, hey, this is a block of like C imported code. And this is like using some compiler built in. And in this compiler built in, you can do something like, hey, I want to use this library, zlib. And I don't really know what this C import block does, other than I know that if I were to just write C include directly like this, it yells at me and says like, hey, you can't do that. You can only do that inside a C import block. So C import must like set some sort of compiler state so that these, like, you can do, like, include multiple things at once, blah, blah, blah. And then you have, like, this constant where you have all of your C stuff. Then we would need to look up what the fuck the zlib API is and try to use it. And I've never actually done that. But I feel like it's probably not going to be too hard. Okay, so let's see. There's like, should be like an include path in here somewhere. Fucking Nix with its fancy shit. Is this it? Zlib? Yeah. So we can cd here. Okay, there's some weird messages in chat. I'm going to have to delete some of these. Apologies. But, we're gonna have... yeah, we'll just, if we keep going with those, we might have to get a little bit crazy here with some timeouts and bans. But for now, we'll just delete them. Okay. So, how the fuck does a zlib API work? I think that they call it inflate and deflate. And I think that we are deflating because we're taking a big thing and turning it into smaller things. Let's see. So, initializes initial stream state for compression. Zalloc, Z-free, and opaque must be initialized. Zalloc and Z-free are set to Z-null. If Zalloc and Z-free are set to Z-null, deflate and it updates them to use default allocation functions. Total in, total out, blah, 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 are initialized. So they have some Z stream thing. The compression level must be Z default compression, or between 0 and 9. 1 gives best speed, 9 gives best compression. All right. Deflate init returns Z okay of success, Z mem error if there was not enough memory, Z stream error, blah, blah, blah. Okay. So it looks like... why is this like commented out? Why... Oh, I see, because... I see, because it's like macro defined somewhere else. Okay, sure. So in here... Do you have over a decade of experience in Zig? I have like maybe like 3 days of experience in Zig. we're not that deep in... I guess I shouldn't say 3 days, because even though I've only streamed for 3 days, I have been kind of playing it with it offline. But, dude, I don't know if you guys get this, but when you're sick, like, I just get so fucking stupid. So, like, I was just trying to, like, try anything, and I was just like, oh, just struggling so hard on just, like, the most basic of things. But, thank God we're hopefully a little bit out of the weeds there. Okay. So let's say that we wanted to, like, compress something. Did you know that Zig stood lib has zlib already? Stood compress zlib? I did not. Why? That's crazy. Zig standard library. Zig isn't even 5 years old. Oh, were you making a joke like those resume things where like we need 100 years of experience in C++ before you can even apply to this job? Dude, those are so stupid. Okay, compress. Zlib. So does this, what does this guy do? So he imports flate, deflate. Oh, whoa. Oh, hold on. Are we, is this already done in the standard library? Wow, sick. That's kind of fun. So zlib are, I think the Zig standard library does not depend on libc, which means that all of this stuff is, this whole concept of rewriting zlib in Zig is actually already done in the standard library. That's pretty funny. No cheating, close your eyes. Yeah, I agree. Ah! Run. Okay, so that's pretty interesting. No peeking at the answer key. Yeah. So, okay, now I have to think about how do I want to do this? Do I want to use the C API or the Zig standard library API? I kind of wanted to try the C interop anyway, so I'm probably just going to keep going down the route of using actual zlib here. And stream? No. We're still doing it. You can't stop us. I think that probably if I'm like trying to say like, well, I want to get familiar with zlib and how it works, etc., then it probably makes sense to use the official. What the fuck does official mean in open source software? Use libz on my system. I think it makes sense to use the C API and kind of feel it out because I think that's probably more applicable in the rest of time. So we'll do it that way. And also it gets me more familiar with like using C libraries from Zig and stuff. So we'll say, even though the standard library has all this, we'll ignore it. Side note though, the fact that he has xz implemented by hand in here, I'm assuming, let's just double check. xz isn't cheating. It kind of like, I wonder if you dodge that whole xz fiasco by using Zig in the standard library. That's kind of funny. Okay. So what we're reading? We're reading that we have to initialize this alloc and free and opaque thing in this zstream thing. So let's maybe make a function, compress with zlib, and we'll take in like a thing to compress. So input data is going to be some like Zig string, I guess. I guess technically it's not necessarily a string. It's like just a bunch of bytes that happens to be a string. And he returns void. Maybe he fails in some way. I guess we'll see if he fails in a second. And we're going to, I guess, make this zstream. Zstream is equal to C zstream. Zig devs backdoored their own xz too. Yeah, dude, that'd be crazy because you need to keep compatibility, right? So it would actually be a breaking of the API if you didn't backdoor your own xz. Okay, so now we have to initialize the parts that we care about. So I think that we saw in deflate init docs that I have to set zalloc zfree. And I guess what zalloc zfree, hold on, initializes blah blah blah. The fields zalloc zfree and opaque must be initialized by the caller. The compression level must be this thing. So zalloc and zfree. I assume that this means that this like supports our own malloc and free, which means that probably we should use the Zig allocators, which kind of makes sense to me. So const allocator is stood mem keep mem allocator. Okay, so here we're gonna do something like, and what is these fields? Alloc, free, and opaque. Private data object passes zalloc and zfree. So zalloc takes in opaque. Oh, that's pretty sick. So it's not assuming global state there. Okay. So let's say that we have some zalloc function, which is going to take in a void pf. I'm assuming is a type def for void. Type def void pf. Oh, sorry. This is a type def function pointer bullshit. What is void pf? Where does that come from? Probably zconf. Okay, so void pf comes from z void pf. And does z void pf get defined in here? No? Where the fuck are these coming from? Am I high? All zlib type defs in zlib.h and zconf.h. You say z like the British? Whoa, whoa, whoa. Do I? I've been saying z and not z. Isn't z British and z American? Oh, I said z one time. That's funny. I do live in Canada. Did I say Zed Alec? That's pretty funny. That's yeah, because I think what happens is we get a lot of American media and we live so close to America and Canada that like we use a lot of their things, but like officially, like we're not supposed to spell like color with we're not supposed to spell color C-O-L-O-R. In Canada, it's color with a U, and we're supposed to follow like Commonwealth conventions. But we don't all the time. Armor with a U as well. Yeah, there's a lot of them. Okay, so where the fuck? So these define. So they're saying, oh, if def z prefix. Oh, but with z prefix isn't set. Okay. So where is void pf coming from then? Type def void star void pf. I see. And far is probably some hint that they're defining to be like, no, dude, this is not a close pointer. If my system is 16-bit, then my pointer might not be within 16-bit. Sure, fine. Okay, so it's just a void pointer. It's just a void pointer. And what's kind of confusing here is, depending on like the compilation options of zlib, then this like void pf might not be the same thing. So I guess I have to say that my p or data, user data, I'll call it, or maybe we should just call it opaque. Except that's a keyword in this language. So we'll call it user data. Canadians are fake Americans. A lot of the time, yeah. In a lot of ways, no, but in a lot of ways, yes. I guess I can just use the void pf type. Dude, this interop with C is so sick, by the way. Like, the fact that everything just works. I don't have to do any, like, bind gen shit. It's just, like, it's just built in the language. It's so nice. Items is going to be a CU int, like this. And size is a CU int. That's so sick. And we need to return a void pointer. And, I think that there's some, like, attribute I have to put on this function to say it's a C function. But I think we'll just see what the compiler yells at us for eventually. So here we should now be able to say that, like, what are we going to do? How are we going to do this? We're going to say our user data is going to be our, like, allocator interface. So I guess we're going to say, hey, our allocator is going to be a pointer cast, which these @ symbol compiler built in. So the compiler built in, take this thing and turn it into the thing I actually want. So here I say, hey, I want an allocator. I guess I want a pointer to an allocator. Yep. And then I want to return like alloc.alloc. And I want the type to be U8, probably. And I can't remember the other parameters, fuck. Type and n. So here I want items times size. I guess this is kind of sketchy because you need some sort of like alignment here. But he's not defining the alignment? Is there like a alloc with options? Is there like an equivalent of like calloc? That's we'll try this and we'll see what happens. I'm not really convinced that this is like correct, but it's fine. And this guy can error out and he's gonna return a slice. Allocates an array of n items. Oh, is this, maybe that's not what I want. Is it raw alloc that I want? From within implementation of allocator? No? Okay. Create. Creates a pointer to undefined memory. This is what I want. Oh, but then I need to say my comp time type. And I don't have a type. So I guess an array is right. Okay, I guess we'll see what happens. So I guess here we need to, this is expecting something that will never fail, which means that I guess we have to just crash the program if it does fail, which is pretty reasonable, I guess. So we'll say, hey, if we have an error, we'll say std debug print allocation failed for this reason, and we'll write the error down. Okay, and then we panic. Std process. Is there debug panic? Yeah, here we go. Oh, and I guess I just write panic here instead, and then everything else just works. Okay. Cool. Does this panic? Are panics disabled in release mode? Because I know assertions get disabled in release mode, but I assume panics don't. But let's see. Function is used in Zig language for code generation and therefore must be kept in sync with blah, 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 default panic. And this guy, I don't see anything about like debug or release mode in here. It's pretty deep, but yeah, it does look like it's just unconditional. I think we're chilling. Don't want a backseat, but any reason not to use std log error there instead? I didn't know it existed. Let's see what's in this log module. Standard index interface for logging, blah, blah, blah. I'm assuming... Ah, I see. So you're saying I should error log and then panic after, instead of doing like a std debug for print or something like that. I'm just going to do this for now because I don't want to learn about the logging module right now. Turn C or something. Export C. We'll see what it'll complain. It'll complain. So now I can do something like Z stream Z alloc is equal to Z alloc. And we have to do the same thing for Z free. Which takes in, what's the Z free API? It's opaque pointer and address. So we just, this is adder is a void pointer, and then we have to say allocator dot destroy, and we take the adder. And is this a failable thing? No, this is unconditionally successful, so. And I think this is void. Okay. Z stream Z free is equal to Z free, and then we need to create our allocator. Oh, we have the allocator. So here we just say that the... I guess we take this in as a pointer. I guess it doesn't matter. Z stream dot opaque is equal to alloc. Okay. I guess technically function parameters are constant. So this might, I don't know if alloc can be used on a constant API. It does seem like it's fine. Seems like it's fine. Okay. And then we just say, okay, so we have this Z-stream, we need to initialize it. So deflate init with Z-stream or something. Let's try calling this compress with zlib. And we pass in our allocator and our input data. And I guess we'd say, hey, we're not going to use this input data right now, and then everything should compile. C import failed. Okay, so let's tackle that. So if I remember correctly, you have to say exe link system library 2. I think 2 is the one that we're supposed to use, because otherwise it doesn't, I think. Because it has like extra options or something. And the name is zlib. Maybe it's just z, actually. And we'll use default options. And then I think I also have to link libc as well. Alloc will be invalidated when you exit function scope. Yeah, I'm not worried about that though, because since the function API is compressed with zlib, then I'm expecting the full zstream to be like deinitialized by the end. Missing field next in. Oh, interesting. So he's complaining because all of these guys need to be zeroed out probably initially. Or maybe I just say it's a zstream of undefined. Because we expect that the initializer will do everything we need it to. And now it's telling me, hey, we're supposed to write call conf c here. And yeah. So it's here. Okay, let's try that. Pointer cast increases pointer alignment. Ooh. There's a lot of fun stuff in here. So can I know that I'm using this thing that has the alignment I need. So I guess I could specify alignment on the function arguments, but then the type signatures wouldn't match. So chatter is saying that I should use align cast, which I think makes sense. Also, apologies for just saying chatter. I just don't know how to pronounce that combination of letters and numbers. Okay. Two-step. Oh! Yeah, I'm seeing it. The 0's an O and the 3's an E. Okay. I see it. Cast discards const qualifier. I see. So I could just say, fuck it, we'll take in a pointer. But really, I don't care about the const qualifier. So do I do like const cast here, like this? I don't give a fuck. Invalid built-in function. I could have sworn I saw like zlib const cast somewhere. What is zlib const cast? Zig. I think I saw in the pointer cast documentation, he says use const cast, which I did. Const cast. Invalid. Const. Oh, it's because I cassette, not cast. Dude, you're catching cassette in there is crazy. That's like very, like you're reading at a rate that I am surprised by, because I was on screen for like 1 second. Okay. So now he's mad that expected type any opaque found U8 slice. Okay, so this is what I was worried about. Oh, this is Andrew Zig writer himself. Hello, welcome. This is an honor. Apologize for butchering use of your language. Okay, whew, just joking. Whew, you scared the shit out of me. I was like, damn, the pressure's on. You guys could have just rolled with it. You guys should have just run with it. And then everybody on YouTube, because they can't see the chat, they would have just thought I was telling the truth. It would have been sick. No, I'm just kidding. Don't lie to me. Don't you do it, chat. Don't. Okay. TVH, that Andrew K at the start of his name scared me too. I was seeing it, I was like, that's not the guy, is it? That's not the guy. But then somebody in chat said, I was like, is it the guy? Fuck! Slice pointer. Slice. Oh, I see. So I'm supposed to just take the pointer out of this guy. So, here, like this? No. Var ret slice is equal to this thing. And then we return slice pointer like this. return slice pointer. Unreachable code? In what way? And also, oh, because I put return here. But then also, then this free is going to be kind of fucked, right? Oh, but the adder is just the pointer. Okay. Expected 2 arguments, found 1 for deflate init. Okay. So let's look at that. Deflate init. So level is the compression level I want. So here I just pass in, I think it was saying that I can use Z default compression. Okay. All right. So now what? Oh, I need to use return value. So he said he returned Z okay on success. So if this is not equal to CZ okay, then we return error zlib init or something. Doesn't fucking matter. Does not matter. Which means that this guy needs to have a little exclamation point on him, and down here I need to write try. Okay. So this guy somewhere doesn't like that I am trying to use a union pointer and optional, probably on this Z free. This takes in a... So this void PF is probably turns into an any-opaque here. And so because the allocator is working on non-null pointers, I have to unwrap this thing. So I just say var adder... I'll call this adder opt here. I don't know if this is like a pattern that people use, but because I can't read like alias names, what is it called? Shadow? No shadowing in this language. Then I need to actually make a new name for the thing I actually want to use. So I think we can just say, hey, if this is a null pointer, like fuck off, right? That seems pretty reasonable. You could argue that it's an error, but I don't give a fuck. It's fine. No size available for type any opaque. Is there really no backtrace here? How the fuck am I supposed to figure out where that compiler error is coming from? Great. No size. Size of t equals 0. So we can look at allocator zig. And this is in destroy. BTW, we don't need extra scope, or else return is fine. Oh, good point. Good point. Okay, so they don't like that on destroy. I'm trying to destroy this adder because they don't know the type of it. Oh. Gross. Oh, that's nasty. Interesting. So, because the type of the pointer is going to determine its alignment, and so he needs to know the alignment of the type. So, but when we called alloc, he called it with some sets of parameters. So I guess, well, okay, so what's needed here? We have alignment and return address. Okay, so do you need to cast to like a U8 pointer? That seems reasonable to me. Seems reasonable. I wonder if we can like do something like, this is a pointer to some U8 data, and then I can do pointer cast like this. Maybe. I guess I pointer cast the whole thing. Like this. Okay. Pointer must be a single item pointer. Maybe you meant to use free. Does that exist? Free an array allocated to free a single item. Use this right. Nice, nice. That does seem like what I wanted, eh? Does seem like what I want. So, can I do something like this? Any opaque has alignment 1, so here I have to do a line cast. Again. Expected T, so can I cast, I can't cast this to a slice, can I? That seems fucked. No. So, can I don't think I can put an underscore here either, like it's asking me, because it doesn't know the array size. So on alloc, we like take the array, we know its size. Oh, it's so annoying. You're saying to do like a pointer, like a slice pointer like this, but I think that I tried that and it doesn't like it. Yeah, because he's expecting one of either a slice or a pointer to a fixed size array. And we just can't do that because we allocated a slice, but then we discarded the length data. So we just don't know how big the thing is. All right. Fuck it. Fuck it. We're going to let it use malloc and free. I don't want to deal with this. This is more complicated than I thought it was going to be. So we can just do it. We can just let it use malloc. You know? Let it do what it wants. Fun little experiment, but we'll let it do what it wants to do. Okay. So now, how does deflate work? We pass in the stream, and then we flush it. Deflate compresses as much data as possible. It stops when the input buffer becomes empty or the output buffer becomes full. It may introduce some output latency. It may introduce some output latency, reading input without producing any output, except when force flush. Oh, I see. Sure. So that means that I have to provide data into the output buffer, I guess, which I guess must just be as part of like the zstream struct. So zstream, next of output byte will go here. Okay. Where do I give it like data? And then there's deflate end. How do I like feed it? Deflate sec dictionary, deflate get dictionary, deflate reset, deflate params, deflate tune, deflate bound, blah blah blah. Where's the part where it just tells me how to like feed it data? Okay. Deflate compresses as much data as possible and stops when the input buffer becomes empty or when the output buffer becomes full. So it's surely going from some input to some output. Compress more input starting at next in and update next in and avail in accordingly. Generate output starting at next out and update next out and avail out accordingly. Okay. So next in and next out. Next out, next in. Ah, okay. So here, I guess I probably just set these guys by hand. And then hit go? Probably? I guess what we could do is we can log our zstream and just see what it looks like after initialization. That seems reasonable. So std format debug, or sorry, debug, std debug print. Here we go. And I think if we just type any here, it'll like auto serialize the struct, which is pretty fucking sick. And we can just look at zstream. And I'm so used to automatic new line appending, so I have to type the new line after. Finwell raids with a party of 6. Hey, thanks for the raid. Appreciate it. What's up, you guys? What is up? Dude, what a type name here, huh? I guess so the C import gets cached in like this very specific spot with a specific name. And so we end up with this like funny fucking type for C types. Interesting. So this guy looks like this AAAAAA, I believe, is Zig's like debug sentinel value for undefined memory. Because they have like, what is it? They say they have like detectable illegal behavior and undetectable illegal behavior. And so they call things detectable illegal behavior if like you want to turn off the safety guards. This would just end up being like whatever's in the stack. But when you're in debug mode, they say, okay, you type the word undefined, we'll give you a specific value that is undefined. And then when you see that, you'll go, oh, fuck, I used uninitialized memory. I bet you that this in hex is the same. If we did like print formatted as hex, format this thing. I think it's this. How do you fucking do a hex formatting in Python? God damn it. This was supposed to be the quick way. It is. Oh, maybe it's capital X. Unknown format code X? Oh, it's because I put it as a string, so I'm a fucking dumbass. Yeah, yes, this is a bunch of A's. This is a bunch of A's, like I thought. Okay. So that means that the initializer for zstring for like deflate init did not touch these guys. And then did the docs say that they expect them to be set? I think it didn't. I think I can set it after. Expects these, expects compression level, deflate, returns the okay, blah blah blah. Okay, yeah, so no error, so we're probably chilling. You could also do number : x. Oh, that makes a lot of sense. I've never done it that way, but that's obviously, that makes sense. Cool. Okay. So I guess now we just set the inputs and outputs. So here we say zstream next in is equal to input data pointer. zstream.avail in is equal to input data dot len, and zstream.totalin was totalin set. Totalin was already initialized to 0, so we don't have to worry about it. Then we do the same for out. So zstream next out is going to equal some output buffer. So I guess he's going to be like what's the syntax here? If you want to like zero initialize an array in Zig, you do something like 0, 4096 times or something. It's something like this. I think it's, I say, I want some U8s. And I do this, maybe? Expected semicolon after expression. I have a semicolon. I swear it's something like this. Zig 0 initialize array. But I guess I don't have to 0 initialize it. I can just say, hey, I've got 4096 bytes. And I want this to be undefined. 4096 is a lot. I don't know what like Zig stack size is. Like I know that it's 8. I think pthreads does 8K by default. Pthread default stack size. BDW if you stream Zig. If you stream more Zig, Zig Discord has a streams channel which you can post in. Oh, interesting. Little free publicity. I seem to remember it being 8 megs. That's way better than 8K. Okay, 8 megs I don't give a fuck about. 496 and an 8 meg stack is fine. That's fine. It's insignificant. Okay, so then we say, hey, you can write this output buff. Can I not type pointer here? I guess I can, but the language server doesn't want me to. And avail out is going to be output buff len. All right. Zig build and run. Oh. I typed next in. Is this like, he's a pointer to a slice, but he wants a C pointer to a slice, to a U8. And also he wants him to be non-const. So there's probably some sort of like, can I just type pointer cast here? Probably not. I probably have to do some sort of like, oh, const cast as well? Expect to type C uint exfound usize. Okay, I don't really give a shit. So this can be int cast. Oops, wrong one. I guess I need to do both. And no field name pointer. So how about and output buff? That's probably more correct. All right, there we go. So we have done this thing now, and then we say, let's call deflate. And what's like the exit condition of deflate here? As much data as possible. Okay. The detailed semantics are as follows. Deflate performs one or both the following actions. Compress more data starting at blah, blah, blah. If all input can be processed, we update these guys, and next time you call, we'll start there. Generate more output. Update next out avail out accordingly. This action is forced if the parameter flush is non-zero. Forcing flush frequently degrades the compression ratio. So this parameter should be set only when necessary. So I guess with our current understanding of Huffman trees, that makes sense, right? Because you are going to feed it some data, and it needs to analyze a full block before it like decides what the Huffman tree for that block should be. And so it will only ever write once it's got enough data to fill up a whole block. And I would guess that under the hood, it's probably updating the Huffman table and then recompressing and checking the size, unless the block size is determined by input data size, not output data size. Not sure. Okay. Normally the parameter flush is set to Z, no flush. Okay. Partial flush, all pending output is flushed to the output buffer, but the output is not aligned to a byte boundary. All of the input data. Okay, who cares? So he's going to return some value, an int. So what is like the return type? Return Z okay if progress has been made. Z stream end if all input has been consumed and output has been produced. Z stream error if the store state was inconsistent. Okay. Zbuff error if no progress is possible because avail in or avail out is 0. Okay. Sure. So for our case, we're just going to assume, I guess, oops, this is the wrong window. That's why I can't get back to my program. I guess we'll just assume that this will work. So let's say that we are going to call C deflate. And we're going to call deflate on the Z stream with Z. I guess we'll force a flush because we think that we should write the whole thing in one go. And we'll say if this is not equal to Z stream end, then we will log an error like that guy pointed out we should do. And we can say we don't have any parameters. We'll just say, what do we say? Zlib or compression required input data could not be compressed into a small enough block. And then we return an error. Okay. And then we should be able to, I guess, return the compressed data. And if we return a slice here, we would have to return a reference to the data on the stack. So I guess we should actually just allocate data here. Or maybe we take in the output buffer. That seems reasonable to me. We take in the output buff. And then the caller gets to decide, hey, I want to use this 4096 block. Sure. Seems reasonable, seems reasonable. Fuck the system, says Smart. It's a it's a bold name. Dude, being sick sucks. I hate how I don't know if you guys get this, but like laughing just makes me fucking cough. And so if I ever find something like a little bit funny, then I start to go into a coughing fit. It's just like, oh, I just want to breathe, man. Just let me breathe. Fuck. Stupid lungs. Work better. Okay, so this guy doesn't return this U8 slice now. He just says, okay, I'll return nothing. I guess I have to tell you how much of the buffer I filled up. So I'll return a U size. And I guess my return value will be Z stream, total out. How much did I write? Yeah. And then here, I guess we can do some extra checks. We can say like, let's make sure that Z stream total in is equal to the size of the input data. There's probably an assert equal, right? Assert EQ, no, only test, probably expect equal in testing and assert here. So assert that this is equal to input data len, and we can just say all data should be consumed. There we go. All right. So here we'll say var compressed size equal this. And we can even do a little, we can even print them out. We'll say zlib compressed is this thing. And we're going to say output buff from 0 to compressed size, like this. Cool. He doesn't like that I didn't coerce. Please turn into a slice. And then he doesn't like that next out thing anymore. This should go back from and output buff to output buff pointer, like this. Because he's a slice now, not an array. Compression could not be compressed into a small enough block? 4096 is huge. Okay, so we should actually like log the return value. Because I want to know what it is. I want to know. I want to know. What is that? Tarzan? Tarzan, I want to know. This is one of those ones that's been stuck in my head my whole life. Every time I say I want to know something, this part. I think that all the fucking time. Just like my whole fucking life. Okay. What am I doing here? I'm trying to see what the return value is. Deflate returned. And I guess this is one of those times where it's like, why the fuck don't I use debuggers as much anymore? Because this is just a faster way to get this information. Why didn't it not print? Why? Because it returned zlib compress, which is here. So why did I not get this return value? No new line. Fuck my life. Every goddamn time. Every goddamn time. Okay, so it returned 0, which is probably Z okay. So he's like, hey, I made some progress. That's interesting. So let's read these docs again. So he said he returns, what is a int deflate? Fuck. Deflate open brace. So he returns z stream end, z okay. Only if, oh, only when flush is set to z finish. Let's try that. Oh, okay. So that's working. So the zlib compressed data is this. And now we can try to decompress. Let's see if we get the same shit back. And I guess we're at 55 fucking minutes. So we probably say that this is a new section. I thought that would be faster. But as it always goes, you use an API and you get fucking lost. All you need to do is write a print line wrapper. Yeah, dude, that would actually save me a lot, hey? Because I do this just all the fucking time. Okay. So here, I guess, we do the same thing, probably a similar API, where we're going to have some input data and an output buffer. It's actually the exact same, but just the input data is now compressed and the output is decompressed. And probably this is going to look very similar. So we construct our Z stream, which kind of indicates that we should probably do something like, maybe like split out this section into a function. That wrapper being stood log, or just use stood log for debugging. That does just sound better. Like in a lot of ways, that's pretty funny. Because then I could say stood log debug, and then at the end I can just like turn the debug logging off. It's just like a better way. But instead I'll just keep getting fucking mad at myself. How about that? Okay, so I don't want to do this. We'll just say pub function make zstream, I guess. I guess zstream, maybe, with a capital S. Because there's a z underscore stream in the type, so there's kind of supposed to be 2 words. And we return an error or CZ stream. Yep. And that's this stuff. Like this, boom, boom. And then here we say var z stream is equal to make z stream like this. And then down here we do the same shit. Here, let's look at the API to inflate now. I'm assuming that inflate is going to actually just use the same structure, and I'm going to actually do the exact same thing, where I'm going to set this next in and next out. It's just in now refers to compressed data instead of decompressed data, which kind of means that in this function, I should just take in input as a const u8 and output as a u8 slice, and then I can just put this shit in here. Boom, boom. And then here I can say input data output buff. And then here I can do the same shit. And then here I'll just have to call deflate instead, or inflate instead of deflate. And I assume that this is actually going to look very similar. Should I read documents? I could either read docs, or I could just blindly try stuff and then get mad when it doesn't work. And it's like, why would I read docs if I can just get angry and guess, you know? Var zlib decompression buff. And I vote for the latter. Me too, me too. Every time. And so we will then say we are going to decompress. Decompress with zlib. And we're going to take our... I guess calling this output buff is kind of confusing now. So we're going to call this zlib compression buff. And then we're going to say, hey, we're going to take the zlib compression buff up to the compressed size. And then we are going to take our zlib decompression buff as our output. And that's it. And then we can just log the decompressed stuff. So we log it as a string, probably. And then we just take zlib decompression buff up to decompressed size. Like this. Alright. He doesn't like that because use of undeclared identifier input data. Where? Compress with zlib, blah, 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 input data. Not so fine. Make, this is input data. And this is, output buff. There we go. Ooh, what's going on here? Because here I didn't write try probably somewhere. Make zstream try. Make zstream try. Okay. And then I need to coerce this guy. So I say, hey, I want you to be a slice. And so if you become a slice, I'll give you $1,000. And then he'll be like, okay, I'll do it then. Little coercion. Deflate return -2. But I think this is... Oh, interesting. Input data could not be compressed into a small enough block. Why is this changing behavior? Shouldn't this be exactly the same? I didn't change the input at all. I thought. So here I have this like pointer with 44 bytes in, and next out has this mode with 4096 out. And so he's like, deflate return -2. I don't think I changed this at all. So this is gonna be like a z okay style variable. So this is 0. Z need dict. Maybe. Let's read this again. Z mem error if there is not enough memory. Z stream error if any parameter is invalid. Z version error. Okay. Z stream error. Oh, here we go. Stream error. So if the stream was inconsistent, so next in or next out was Z null, or the state was inadvertently written over by the application. Okay. So let's look at that. So in memory address 44, total in 0. Out, memory address, total out 0. So he's saying that there's some sort of problem there, but I don't see it. I don't see the problem. I guess this is one of those times where it's like, let's just fucking bust out the debugger. That just makes so much fucking more sense. So GDB target GDB? Yeah, okay. Oh, it's not target in this language. Zig out, bin, ziglib. Okay, break, here, run. Run, input data. I guess I need to run with the same input data. Over the lazy dog. Okay. Next, pret. So ret was -2. And let's look at Z stream here. Sorry. I don't know if you guys heard me like fucking snorting up some fucking snot. But that was fucking disgusting. And I apologize. This is what happens when you're just like sick by yourself for a week. And then you like go on the internet, but you still feel like you're by yourself a little bit. And so you just start like fucking... I'm just like, oh, okay, I'll just fucking snort. Like, oh, it's disgusting. Sorry, guys. Yeah, I don't see any problems with this. Available in, total in. Available out, total out. Next out is this. What the fuck is the problem? I don't understand what, like... Where am I? I am in compress with zlib, and I got -2. Yeah, so this is in deflate. Z stream error if the stream state was inconsistent. Next in or next out was Z null. No, state was inadvertently written by the application. I feel like I'm losing my mind. It must be related to the pulling out of this like make Z stream stuff. But for the life of me, I'm not seeing it. Okay, so let's do this. We'll go back to the old way. And see if we still get that error. We do. Oh, inflate returning of 2. Oh, okay. Interesting. Very interesting. Okay, so if we copy paste this code out of this make zstream function, then it's fine. Which is very strange. Which kind of indicates that this undefined memory is not actually being fully initialized, which is surprising. Surprising. Very odd. So it must be something in here we just have to set and we're not? Maybe use stdmem0 in it. Yeah, it does seem like I should. Definitely seems like the right play. But I'm surprised that it's not complaining to me anyway. I wonder if I run this under Valgrind. If it'll yell at me. Now, this is just more for curiosity's sake than anything. Oh, also, I'm probably not freeing... I probably just never freed the Z streams, which is bad. But I just want to see... Okay, Valgrind, zig out, ban zlib, input data. Boom. Alright, so lots of stuff here. Use of uninitialized value, which is very nice. That's great. So that means that like we're catching something that we're doing wrong. And this is in compress with zlib 147. And does it tell us which field? I guess we can probably guess by looking at this. Oh, I guess maybe that's fine though, because maybe there's some like uninitialized fields that like technically wouldn't actually need to be initialized, and by printing them, we're iterating them all. Seems possible. So let's take out this print and see if it still bitches at us. And then let's can we like return early here? I just want to like reduce the things that it could be complaining about. If true return. Oh, that's a good trick. That's a good trick. Good to know. Input data. The quick brown function for the least dog. It's still printing here. Am I high? Let's not print this, and then oh, here. Well, okay. Oh, it's because I didn't fucking compile, because I'm an idiot. That would do it. Okay, so here he's no longer complaining about use of uninitialized memory, which is surprising. He is complaining that I didn't free, so that's a big no-no. It's probably like C. What's the function here? We said deflate init, so deflate end. This should free everything, probably. which he doesn't like because I need to put this as a pointer. Value to C int ignored, so let's just, I don't know. This is equal to nothing, I don't give a shit right now. We do still lose one block here. Interesting. I guess that could be from anywhere though. Did I like fuck up my like argument parsing? Who knows? Who knows? That's kind of fun. Super fun. I guess we have to read some docs. Deflate init. So here he should tell us something about allocation. Compression level, blah, blah, blah. He actually doesn't tell me that I have to call deflate in, which is kind of surprising. It does say that all dynamically allocated data structures for the stream are freed. This function discard any unprocessed input and does not flush any pending output. Okay. And I guess we should check if it's Z okay. I guess. So what? We do like defer this block and we say if this is not equal to Z okay. Can I call this red? Is that gonna be mad at me? I think it's fine. Although I should get out of that habit because there's no shadowing in this language. Oh, for now it's okay. And we'll just here stood log error failed to deallocate or to end deflate. And I guess we'll just write the error here. And yeah, sure. Failed to end deflate, -2. Ah, so because the compression failed, then the deflate. So you really can't free internal state in this case? Oh, because the stream state is inconsistent, so I couldn't free stuff, I guess. That's crazy. Very interesting. Okay. So we have to go back to actually solving our problem. So let's start here by doing stood mem zeros. What's the difference between 0 init and zeros? 0 init initialize all fields of the struct with their default value or 0. Ah, okay, I see. I guess I'm still going to use zeros here, but maybe I shouldn't, but that's okay. Let's see if that changes the behavior. That actually still does fail to end deflate, which is interesting. Very interesting. I guess maybe there could be some internal pointers in this internal state. Maybe. And maybe by copying the struct, we actually end up with pointers to memory that we shouldn't. Right, because what happens here is we allocate a thing on the stack and then copy the thing out. Maybe. Right, you could implement it that way. Theoretically, Zig might be smart enough to go, hey, like this thing is going to be returned at the end, so we don't need to mem copy it out. You could just write directly into the spot in the stack, but probably it's copying it out. And we should assume that it is. So it could be that we actually have to take in let's try, okay? Hear me out. We'll try returning a pointer. That way we know that it never moves. And then here, we have to take in an allocator. Ah, fuck it. We'll just take in the Z-stream here. Like this. And here we will return void. And here, we'll call this init Z-stream instead of make Z-stream. And then here, we're going to say var z stream is equal to something. I guess we'll undefine it here, and then here we'll mem set it. We'll just, fuck it, it's fine. This is going to initialize it. Let's just see if this changes behavior. And we have to do the same treatment over here. Classical indices are greater than pointers. I mean, to be fair, this is just the theory right now. We don't actually know if that's true, but that's my guess. He doesn't like something here. Oh, because now probably here I have to take away this ampersand. Because it's a pointer type now, not a concrete type. And here we're trying to return it. We don't need to return it. Get the fuck out of here. Very interesting. So that's just working fine now. God, fuck that. No, ugh. What a fucking garbage. I shouldn't say garbage, but just like, come on, man. Right, there's nothing in here that, like, obviously tells me that I shouldn't be allowed to do that. Right, nothing about this indicates that that's a problem. And now I just, like, want to prove to myself that that's true. So wait, so what did I change? So before, I was returning a thing that I made in this, like, initializer on the stack and returning it out. So in my mind, doing a mem copy out from an inner function to the outer function, but calling deflate init in this context. Now I pass in the z stream as a pointer who lives on the stack outside, and all of a sudden everything works okay. So now, oh, that's so okay. Let's go back to the old way, where we return the thing from the stack. Because now I just fucking need to know. I need to know. Can you help me? And so here we were doing var z stream was a cz stream equal undefined. Right? It's the fucking same thing. And so I want to say, like, okay, var z stream 2 is equal to make z stream with input data and output buff. And, like, what the fuck is the difference between these? Like, these would be the fucking same thing. So can we do, like, stud meta? I guess we'll just print them both. Stud format debug. No, debug, stud debug print. That's the one. And we're going to say, fuck it. We'll pop on the debugger. We'll pop on the debugger. That makes more sense. So zig, build, and this, and then we break it. Ooh, he doesn't like that. Error is discarded. Right. Now what's he complaining about? Oh, probably in the make zstream version, I had to cast this to a pointer. Yeah, like this. Okay. Break on this line. Run it. Oh, run with input data. The quick brown fox jumps over the lazy dog. If it's UAF, you might not see any different debugger until some stack usage. UAF, undefined, abnormal fuckery. Not sure what UAF stands for. Use after free. But I don't think it should be because I'm not actually using it anywhere. But I get, like, I don't think. This should be break at 164. Where was I breaking before? 166. 164, okay. And then let's run with input data. The quick brown fox jumps over the lazy dog. Okay. List is how I see where I am. So I'm at line 167, which is here. Okay. So let's print z stream 2. Is it optimized out? Thank God. Okay, so zstream. Whoa, 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 whoa. Hold on. Oh, fuck, we ran deflate already. What the fuck? Oh, because I'm in the fucking defer block like an idiot. I should be breaking at 174. 74. Run. Input data. The quick brown fox jumps over the lazy dog. And it's like, do you think that maybe I should make a GDB script that does this so I don't have to fucking type it every time? Maybe? Yeah, I should. You can't make me, though. Okay, bz stream 2, bz stream. Yeah, okay. So these guys are almost exactly the same. The only difference between these guys is the internal state pointer. Right? Can I look at this? I don't know what the data is in state. But I guess we could maybe print some stuff in state and see if we find anything that looks like this. In the internal state, there's a pointer back to zstream. Like, it's just, how the fuck am I supposed to know that, man? Ugh. Yeah, okay. So, at the very least, I feel like validated. See deflate.h in the zlib source code. Yeah, that's where I was like, that's where we were going to end up, right? I just wanted to check first that I wasn't crazy. And the I'm not crazy is that, like, if you looked at this structure, there is no reason to think that that's going to happen. Right? Because, like, you see the opaque pointer. I mean, maybe I should think that, right? But I see this, like, opaque pointer, and I think, where is it? Sorry. This internal state. And I think, like, okay, so he's a pointer, so I can assume that they mallocked him, right? And so I can assume that any internal state is, like, fine. Was Valgrind catching that? I don't think so. Might have been. I wonder if Zig, deflate and Zig stand library uses internal pointer. I mean, the implementation is probably completely different, so I don't think I don't have to check. Or I don't think it's like worth checking. But it's just like, how the fuck am I supposed to know that? Like, why would I ever assume that what I did wasn't okay? Like, is this like, oh, what bothers me is I hate it when I make a mistake and there's no, like, obvious, well, I should have done X, right? Like, my first instinct when I get something wrong is to be like, just generally, right? And, like, I probably got this from gaming, where it's just, like, the best way to rank up is every time you lose, you go, what should I have done? Even in a team game, you go, like, what should I have done so that this wouldn't have happened? And sometimes, you know, it's like a complex system, you don't always have the right answer, but at least, like, you can make progress. And here's just, like, how was I supposed to know? And I can't... Like, is there some documentation that I was supposed to read? Maybe? Right, just reading this header is maybe not the way. Oh, it's frustrating. I'm not really mad at them. Like, it's just like, why? It just bothers me that I don't know how to, like, avoid this. Let's see, like, zlib documentation. Maybe if we were to read what they told us that we were supposed to do, maybe we would have seen. Zlib compression, uncompressed, blah, 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 blah. Nothing crazy here. Designed to be compact, blah, blah. Stream data structures. Here is the data structure. Yeah. Structures usage. Must update these guys. Must update these guys. Application must initialize zlxc free, blah, blah, blah. Opaque value, blah, blah, blah. Compression library, no meaning. Zlx, yeah, it's just... They don't say anything about not copying it. That's crazy. Yeah, okay. I mean, it's fine. Just frustrating. Frustrating, but at the very least, at least we could diagnose it, right? Which is, I guess, a win. So, I guess we will write down here, note zstream holds internal state that is a self-referential pointer. Copying of ZStream is a big no, 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 no. Okay, that's fine. It's fine. Glad that somebody, like, okay, so I'm glad someone in chat already went to GitHub and looked at the deflate source code, because I will say that the amount of investigation that we did here on stream was not good enough, right? If I were to be doing this somewhere where it mattered, I would say, okay, how can we prove that there is internal pointers? And in this case, it would be go look at the source code, right? But sometimes you don't have that luxury, and it's a big pain in the ass. Probably going down the path of trying to use Valgrind to validate or something would have been the way to go. But another big, like, that's why open source is so great in my mind. Like, the ability to just, like, go and look is so fucking sick. It solves so many problems. Because, like, I used to work in firmware, and you would, like, get this device, and it would just, like, it would be like this, like, black box, and it would say on its spec sheet, this is my behavior. And then that just wouldn't be the fucking behavior. And it's like, what can you do in that case? Well, you just have to, like, fucking poke the box and see if you can fucking, like, get some sort of consistent behavior out of it, and then hope that your mental model of that consistent behavior is, like, correct. But sometimes it's not. But, like, just being able to, like, look at the fucking source code, because in my mind, a library and a firmware device are, like, the same thing, right? You just have, like, API to thing, you do the thing, and it does what it says it does. Like, oh, just being able to look at the source code is so sick. It's so sick. I love it. Okay. Okay, so now, if we go back, we should be able to compress and decompress stuff. Input data, the quick brown box jumped over the lazy dog. He's like, allocators unused, sure. And pointless discard of local variable. Okay. Inflate return -2, so the decompression is still not good. So we initialize the ZStream. And it could just be we never read the inflate docs, right? So earlier when I was like, what the fuck could I have done? Well, in this case, I have to say, well, I didn't read the inflate docs, so this one's on me. This one's on me. Oh, because we just called deflate in it here, like fucking idiots. Okay. So I guess what we'll do is we'll pull this deflate init down here and call inflate init down here. Okay. And he probably now doesn't like that this guy is supposed to be taking a pointer, and he's not, so we put a little ampersand on him on both cases. Okay. Inflate returned 1. Zlib decompress. Okay, so we've got a successful back and forth. It took a fucking long time, but we got it. Which means that the actual part of the stream that I wanted to do today is actually on the very, like, small back half. But we can get at least some of it done. I don't think that we are at the point where we have to say we give up. But holy fuck, that took more time than I thought it would. And I bet if we had just used the Python API to zlib, or the Zig API to zlib, we probably would have been in a much better spot right now. There's something about, like, the low-levelness that makes shit hard sometimes. Okay. So let's maybe try to look at this compression buffer and see if we can look at the zlib header, which, if I remember correctly, is in this RFC 1950. 1950. What the fuck? RFC 1950. Can I just... Here we go. And I think that we should just be able to start, like, looking at the start of the file and see what we get. So zlib has the following structure. 1 byte or bit CMF, 1 byte or bit FLG. It should probably tell us somewhere CMF, which is this guy. This byte is divided, so it's a single byte. byte divided into a 4-bit compression method and a 4-bit information field, depending on the compression method. So bits 0 to 3 are compression method, bits 4 to 7 are compression info. Okay. Let's get crazy. So let's see. Do I think it's worth trying to use like zig packed structs here? This is a 2-byte field, time for packed struct. That's what I was thinking. My like intuition here though says that it might make more sense to just parse this byte by byte, because I think that this, what is this? This is CMF and FLG. What's an FLG? Oh no, this is some packed struct shenanigans for sure. Okay, so let's see. We want to make sure that our like decompressor is using like a writer API, because later we're going to be doing this from a file. So let's do something like zlib decompressor. And this isn't the syntax for this in this language. We are making a new variable that happens to be a type that happens to be a structure. And in here, we're going to have some writer, which is going to have some sort of like compile time known unknown thing. And I guess this is actually going to be our bit, not a writer, a reader, sorry. And I guess this is probably going to be our bit reader. But we don't have a bit reader. We just have a Huffman reader, which is annoying. So we'll call this a reader for now. Which means that this is no longer a function, a type here. This is a function that generates a type, because we're in zig land. So it's a function, zlib decompressor, and he's going to take in a type of reader. Comp time reader is a type, and he's going to return a type. And he's going to return this struct now. Yup. And this struct is going to have some methods. And once like we're going to have like a read header. Is that what we want to do? What is the purpose of life? Dude, it's just to write shitty code that nobody else will ever use. That's all we're here for. And you just have to not think about it too hard, right? And just keep writing shitty code. And if you just never think about it, then you just keep writing shitty code and you're happy. But if you think about it a little too much, then you might be like, wait, nobody's going to ever use anything I write. What's the point? Don't do that. Don't want to get there. Just bury your head in the sand. Make the square wheel and be happy. Exactly. Okay, so probably like the long-term version of this API would have something that's like read, right? And he's going to return some data, and eventually, and as part of the read, we would have some like internal state, and we'd be like, have we looked at the header yet? Have we looked at the internals yet? What do we have to do next? But instead of doing that, we're just going to make a function right now that's called read header. And we will return a header. And I wonder if you can return like a pointer to the header. No, we just give it back a header. And here we have to say const self is equal to this. Welty, thanks for the raid. Party 7. Welcome, guys. Welcome. Still not sure how I feel about the duck typing in Zig. Where's my trait at? Yeah, I mean, I will say that traits are great. Or, yeah, they're pretty good. Like, the compile time traits, I really like that. I didn't like the templating in C++, and I do like the traits in Rust. So I do kind of agree. But I can see why they did it this way. I think it probably simplifies a lot. But yeah, I was going to say that I don't agree with you, but I think I do. I just do agree with you. Okay, so now we return some header, which means that we need a header. And this guy is going to be a packed struct so that we can read him effectively off the disk. This is kind of tricky, because you could argue that by making him a packed struct, all access to fields of him later are going to be slower than if they were unpacked. But it makes the serialization better. So probably what I would do if I were getting like real crazy is I would have like a packed version of it and an unpacked version of it and like allow conversion between them. But for now, we'll just make it packed. Pack that boy up. And he has CMF. So CMF, it was a CMF who is also a packed struct. And CMF had bits 0 to 3 compression method. So U4 and compression info. And I guess we should call it CM and C info to match spec names, even though I don't think those are very descriptive. Hello, bro. Do you know anything about Flutter? I know. Well, okay, I was going to say I know nothing, but that wouldn't be quite true. I know very, very little. I've never done more than Google what the fuck is Flutter. So surely you know more than me. My understanding is that it's like UI framework, and as soon as I see like the words UI framework and like especially if I see the words like HTML or like when my brain just like shuts off. I'm just like, I'm fine with writing things by hand for now. And so I just stop reading. So unfortunately, probably can't help you with whatever your follow-up question was going to be. Okay, then we have our FLG. Also a packed struct. And he has bits 0 to 4 fcheck, bit 5 fdict, and bit 6 to 7 flevel. So now we have CMF and FLG. And then we should just be able to take this guy and read 2 bytes from our reader. So we should be able to do something like var header is a header that is undefined. And then we should be able to do like self reader read all. And then we have to double check the reader API here. Zig standard library. What language you use? We trend towards Rust here usually. I'm learning Zig right now. We've done a little Python, a little bit C, a little bit C++, a little bit of JavaScript. Will fdict as a bool be interpreted as a U1? Yeah, I was reading I cheated. I looked this up a little bit before stream. Zig language reference. I don't know what it's called. I think it's just documentation here. If you look up packed here, they say here bool fields use exactly 1 bit. So I think we'll be fine there. I think we'll be fine. What I was looking for? I was looking for read all. Okay. I'm out. I know Java, JavaScript, Python, Dart, Flutter, that's it. Well, I mean, you could always learn, right? I mean, you could... I watch some streams of people who write stuff that I don't know, and it's, you know, I don't really know if it actually teaches you anything. I don't know how I feel about educational content on the internet in general, even though I am trying to be a part of it in some way, right? There's you can like trick yourself, I think, into thinking you know a lot more than you do, but I think exposure is also good. So it's hard for me to like wrap my head around what the value is of what watching streams is, but I will say that I do think that it's nice to watch. You don't have to leave because you don't write the language, is what I was really trying to say, and then I got distracted in my own head. Okay, so I take a buffer as a slice, which means that I think that there's a way to cast a type to a byte slice in std_mem. I think it's like bytes as value. It's not that, it's like the other way. I want like, give me this structure as an array. As bytes, this one. Given a pointer to a single item, returns a slice of the underlying bytes, preserving pointer attributes. So that will let us take our header and turn it into a byte slice. like this. And so here we should be able to say, if I read this, then we should be fucking good. Oops, this should be try here. And then we should have a header. Which means we should be able to make a decompressor now, which means that in Zigland, you make a function that's zlib decompressor, but he's got a lowercase z at the beginning instead of an uppercase z. So this is a function, not a type, even though this function, this is also a function. So this is a function that returns a type, and this is a function that returns an instantiation of the type. And we take in a reader, which is any type. Any type, I think. And he returns a zlib decompressor, who is a function that we call with the type of the reader. And that is now what we get back. And so then we return zlib return a structure, which will be auto-inferred, and we pass in the reader as reader. Like this. Chat emote of a guy with his head like this. Yeah, that is how I feel a little bit. It feels like on one side, it feels so much better than C++ templates, man. Like, so much fucking better. Like, I was looking at some of the stuff in the standard library today. Like, stuff like, native to little. Stuff like this, where you have, like, some compile time function that takes in a type, and depending on that type, will, like, compile time resolve the endianness of your system and only do a byte swap if you're on a big or like a little endian system or a big endian system. That's so fucking sick. Writing a templated thing to just do that would suck. Or the like fucking allocator API. This is so fucking cool. General purpose allocator. I was looking at like the source for this guy, and shit like this where they say, let me see if I can find it. There was somewhere where they like adjust the type layout based off of like input data, which is just so fucking cool. Yeah, here. So they say like, hey, if your config had some value, this field in this struct is a use size, otherwise it's void. Boom, that's so fucking sick. You try to do that in C++, you just fucking like, you're doing some crazy Symfony stuff. You're using like enable if to write two structures where like one of them fails to compile in one case and the other one fails to compile in the other case, and they have the same name though, so like they end up like, this is just so much better than that. Like way better. But then this is fucking weird. Right? Like this is, I think, easier to wrap your head around than the C++ Symfony stuff. So like I'm a big fan of like the level of abstraction here is just like all you really have to wrap your head around is that types are values, which doesn't seem like it should be that hard to wrap your head around, but then it feels hard anyways. And so I don't really know how to like reconcile that. But so this is kind of weird, but man, do I like it better than the alternative. Okay, so we are going to make a decompressor. Who is going to be call the function zlib decompressor with a lowercase z, and we're going to pass in a reader. So this is going to be the zlib. We're going to take our zlib compression buffer up to the compressed size, and we're going to get a reader to that guy. I think it's a function in the standard library, maybe std io fixed buffer reader, fixed buffer stream. And then we are going to call zlib decompressor read header, and then we can print this header. Std debug print header is this thing. And I think we have to type any here. Not really sure. And I forgot the new line again. Shoot me. Am I allowed to request that someone shoots me like that? Or is that against Twitch terms of service? Feels like it might be. Well, this is one of those things where everybody says in-game. They don't really mean in-game, but then they say in-game so that it's not against the terms of service. Right, this reader thing. So I have to make my stream here. So I say my var compressed data stream is equal to this, and then I get the reader from the stream. Like this. And then I think that all the APIs will work out. Nice. So, we got a thing. We got this type, and we have CMF is this thing, and we got CM8, CInfo7, fcheck 12, fdict true, flevel 0. So let's see if those make sense in any way. Linear FIFO public API is cool. It can use alloc, or it can work with a buffer, so it can use an internal array. Is that like, are we talking about comp time shenanigans? Linear FIFO buffer type. Oh, interesting. So this guy probably like generates an init function in some way, like somewhere you would have to pass in an allocator if you were using the dynamic type. So it might like do some sort of shenanigans to change your init function. Oh, it just has init dynamic. No shenanigans, no shenanigans, which is probably better. Okay, what were we looking at? We wanted to see if this was sane. So our compression method was 8, and CM equals 8 means deflate. Great, perfect. So that's a good sign there. CInfo, we got 7. So values of CInfo above 7 are not allowed in this version of the specification. Oh, interesting. Oh, we're not above 7. We are 7. CInfo is the base 2 logarithm of the LZ77 window size. So CInfo 7 equals the 32K window size. Sure. Flags. Do our flags make sense? So we have flag fcheck 12. Check bits for CMF and FLG. Fcheck value must be such that CMF and FLG, when viewed as a 16-bit unsigned integer stored in MSB order, is a multiple of 31. Oh, I see. Okay. So what we do here is we can check that. We can check that. So we can get crazy with it. We can get crazy with it. So we can take our header and we can turn him into, so assert stood debug assert that the header size of header probably is equal to. Then what we can do is we can like take this guy and we can cast him to a byte slice of, or just to U16. Can we do that? Can we get crazy and say like var header U16 is equal to int cast header? There's no way that compiles, right? Absolutely no fucking way. It would be so fucking cool if it did though. And then we can say header dot flg dot fcheck. Here we want to say that they said this should be viewed as an MSB order thing. So the most significant bit, this is big endian. So we just sound big stood mem big to native this. Then we should be able to say that if we take the header as a U16 and add the fcheck, and then we divide this by multiple of 31? All right. We should be able to say, hey, this thing is gonna be fucking 0. I think that's right. Size of header, expected type, found type info. Oh, I see. So this is a header, but this is going to be a member of the zlib decompressor. Or I guess we can do size of type of header. There we go. All right, let's see how fucking crazy this gets. Big to native, we need to specify the type here. So U16. And int cast must have an own result type. Okay, so we say as U16 like this. Now, expected integer or vector found this thing. Okay, so we can't cast the header directly to E16, but we should be able to somehow cast him into an array that casts an integer or something. Ooh. Two-step is saying bit cast to work, which is exactly what I wanted. I'm pretty sure. I'm pretty sure I read somewhere that bitcast is, hey, I'm going to assert that these two things are the same size, and if they are, I'll just fucking reinterpret cast it. Converts a value of one type to another type, asserts that the size are the same, so I don't need to do this assert. It'll do it for me. Convert F32, U32. Yeah, okay, let's try it. Bitcast. Cannot bitcast from this shit show. Oh, error union? Did I forget to try? I forgot to write try somewhere. U16 has 16 bits, but source type has 15 bits. Hell yeah. Hell yeah. Okay, so that's really cool. That's really fucking cool. So somewhere in here I fucked this up. This is 4, 5, 6, 7. Yeah, so F level should maybe be U3, or maybe there needs to be some padding on there. So let's just double check. Bits 6 to 7 is compression level. 0, 1, 2, 3, 4, 5, 6, 7. Ah! This is a U5 here. F check. I'd like to see you on Adderall. I've never thought about that. But yeah, it does seem like that would be a fucking disaster. Sorry. Oh, you know, when you're sick and like when you cough and you like, if you're really sick, you kind of feel like you're gonna, like if you cough too hard, you don't get enough like oxygen into your lungs, and you like feel like you're gonna fucking pass out. That just happened to me a little bit, but we're gonna be fine. We're fine. Okay, so where did we hit our unreachable? It was this debug assertion here. Deep breathes, yeah. And I think that, like, sometimes... No, I don't know anything. Yeah, deep breaths help a lot. Okay, so we are failing here. So let's kind of just rip out the debugger again and just kind of see what we're looking at. GDB... Break here, run, input, data, I don't care. I just want to see it. So, here, let's look at... Header U16 is 30876. Header FLG FJEG. Oh, cannot extract this thing because the packed structure's fucked. Okay. Okay, that makes sense. So let's double check a couple things here. FCheck value must be such that CMF and FLG, when viewed as a 16-bit unsigned integer stored in MSGB order. Double check this. CMF times 256 plus FLG is a multiple of 31. Oh, so we should just do that instead of this bit casting stuff. So here we can say header.cmf as U8 bit cast this times shifted left by 8 times 56 is fine. It's fine. It doesn't fucking matter. Doesn't matter. Plus as U8 bit cast header dot FLG. I think that's what they said we were doing. And look, fuck GDB here. Zig build, and we'll just do this, and then he doesn't like cannot represent. Ah, this should be as U8 as U16. Doesn't type have to be U816, not U8. But like the thing is, like we're casting the thing to a U8, which is kind of annoying. So I don't know if you have to do like this like weird fucking double cast without shift. Yeah, but I mean, I think that the shift, like compilers should be doing that for free if it's a compile time value. So I don't really need to worry about it. Shift 8 cast type. Ooh, you've convinced me. 3-bit int cannot represent all possible 8-bit unsigned 8-bit. Expected type U3 found U8. Oh, because the plus order of operations, baby. Cannot represent integer value 8. Nah, I still have to bitcast first. Ugh. So do I do like bitcast as U8 and then as U16, this whole thing, and then times 256? Gross. Absolutely disgusting, but fine. Okay. So let's maybe std debug print header U16 is this value. And let's print out the fcheck value. And I didn't fucking new line, so I just don't get to see them because I'm a fucking idiot. And okay. So 30876 is already 0. Oh. Ah, I see. So the thing that we probably didn't catch here was that, yeah. So it's not that the fcheck is added in, it's that we already, that these 2 bytes have to be a multiple of 31 already. And so you just fill in the rest of your header, and the fcheck is just set so that this is true. I see. So this like assertion was fucking stupid. I misread this. So this assertion should just be that header U16% 31 is 0. Very cool. Which kind of indicates that we've like read something valid at the very least. We can look at fdict and flevel to see what came out here. So let's print out. Oh, we've already printed those, so we can just look at them. So fdict is false now, and level is 2. Let's see if level lines up with the zlib default compression level. So we can see here default compression. It is equivalent to level 6, which is not what we're seeing here. I wonder if we like hard code a level in here, if we'll see it out the other side. I got super confused by that and didn't realize fcheck was a part of FLG. Yeah, that was my bad there too. Yeah, same thing. Okay, so when we initialize our deflate, say that we just like put a 6 in here. Do we get a 6 back for the level? No, it's still 2. Interesting. I wonder if the level is not if the level has some sort of like dependency on the data itself. 1 gives best speed, 9 gives best compression. So let's say that I wrote 1 here. Here I got level 0, okay. Like 2. I got level 1. Right, 3. Level 1. Oh, so I wonder if this level is not the same as the zlib compression level. That could be it. So f level it's a 2-bit value. Right, so the maximum value is 3. Which means that the compression level from zlib that's 0 to 9 is just not helpful. So here, if I put 9 in for my level, I should get 3 out. I should. Yeah, I do get 3 out. All right. So that's kind of cool. So we've read out the header here, or we haven't read the whole header. We've only read the first 2 bytes. Then the next set is like, if the fdict is set, then we have these 4 bytes here. Otherwise, we just have the compressed data. So that's pretty funny. Like this zlib header RFC is actually like very short, right? Because the most of the actual important data is inside the deflate block. And it's like, is anything in here even fucking interesting? Like, is there any interesting things in this header at all? Why does this exist? Compression method. So I guess that they're provisioning that zlib could, in theory, use something that's not deflate. They're going to use deflate, but maybe you couldn't. So that's fine. I like get that. The window size, I guess that's maybe relevant in some way. I guess we'll figure that out when we start parsing deflate. I would have thought that the compression window, maybe it's not even like really important. I guess we'll see. Maybe this is like metadata, flags. So preset dictionary. What is preset dictionary? Because that's probably the only interesting part. The dictionary is a sequence of bytes which are initially fed to the decompressor without producing any compressed output. Dict is the checksum. Ah, okay. So there's some checksumming here. That's important. We need that. Because like if you decompress something and you just don't get the right checksum out, it's like there was corruption. So you need to have some sort of corruption detection. That makes sense. Then the idea of feeding the data, feeding the compressor some data just to get the checksum at the end, that's kind of interesting to me. I don't really understand why that would exist, but sure, I guess that's interesting at the very least. This is like metadata again, F level, and then checksumming. So there's actually like really not much in here, which means that most of the heavy lifting is going to be done at deflate. We're at the 2-hour mark, so I think that's a good kind of time to call it. It's kind of, we got to something where we read this 2-byte zlib header, and now we're at least at the point where we should be able to start reading the actual interesting stuff in deflate next stream. What do we do today? I guess we struggled with the zlib API a lot. So I guess this is kind of like the argument for why higher level languages are nice. Right? Like, there's no fucking way that we would have spent, what, an hour and a half reading zlib data or like compressing and decompressing something with zlib if we were in Python. It would have been like a few minutes, right? Surely. In fact, I don't. Do we want to try it? I'm pretty sure that the Python zlib API is just like fucking run it. Like, C would have been faster? I don't think so. I think that our struggles with this were not with like C to, oh right, because we spent a lot of time on the allocators. Yeah. Okay, that's fair. There's this thing where they give you the knobs and all you want to do is you want to click the knobs. You want to turn them. You say, oh, we can use our allocator. Let's use our allocator, and then it's hard. But that's not too bad. Bit fields, read and cast. I feel like I'm going to like the zig bit field and packing better than the C stuff. Because I think that the C stuff, I'm not sure if it's like actually well defined if you can just take a C structure and shove it into a file. Right? Like you have like GCC attribute packed and stuff, but I don't think that like packed structs are actually part of the C specification, which means that like just slamming these like values back to back like this doesn't really work as well. Yeah, I don't know. Good stream. Not another one of these like we didn't make like rapid progress like I necessarily wanted to, but we still had fun, learned a bunch, so I'm okay with it. Thanks for watching, guys. If you like what you saw, we're streaming most days around 2 o'clock. Last week didn't get very many streams because I was sick, but I'm hoping that we're back on the grind now, so we should have at least a few days coming up. 2 o'clock zlib zig streams. If you are new here, there's a bunch of like 2 p.m. 1 time zone. Sorry, yeah, I've been meaning to say Pacific time. Sorry, yeah. So if you're online between 2 and 4 Pacific time, where 4 o'clock is now, then you could swing by, see if we're online. If you want to check out like what we've worked on before, there should be a YouTube link in the Twitch description. Some people can't see it, so if you go to the same usernames fair for you on both GitHub and YouTube, we should have like code for past projects as well as playlists for different projects. We've done like some like Rust operating system, some like Rust web dev with some front end stuff, some like Python neural network stuff, some like Rust C interop for like Fuse virtual file systems. There's a bunch of stuff in there. So if you're curious, you can go swing by, check it out. And if you're on YouTube, there should be a Twitch link in the YouTube description where you can swing by and say hi if you feel like it. I think that's it. Thanks for watching, guys, and I'll catch you on the next one. Bye!